Today, you will learn what a delay is, different delay techniques, common problems you'll run into while using delays, as well as the controls you will see on the delay. There's a lot that you can do with the delay, as well as a lot that you can do with the controls on a delay. So without wasting any more time, let's get started. Please smash that like button and subscribe. The delay is comparable to an echo when yelling into a large cave or the Grand Canyon, for example. However, the delay wasn't used musically until the era of the tape machines, when somebody got smart and realized they could do a cool little trick. Before the advancements of in-the-box mixing and hardware versions of delays came along, delays started by splicing together an endless loop of tape. This tape that was spliced together in a loop would run around 3 different heads. If it went in a circle like this, it would hit the erase head first, then it would hit the record head, and then after the record head, it would hit the play head. This tape machine would receive the signal, record it, and then the tape would move along to the play head, where it would play it back out and send that outwards back to another mixer track. Now, the signal coming in to when the signal coming out would have a slight delay. This is because the tape would have to travel a distance from the record head to the play head. And the length and time in which this delay would happen was determined by this distance, as well as the speed of the tape moving around the tape machine. This delayed signal that would hit a new mixer track coming from this tape machine could then be routed and recorded however the engineer decided for it to be kept or used for the final mix. And then as the tape left that playhead and wrapped all the way back around, it would hit the erase head, priming it for the next recording to be used for this delay effect. Now, this is how a delay was used before, but hopefully this gives some context that can help you with the way you use it now. So we'll start with the techniques that use shorter delay times and then work our way out. Starting with short delays is going to create a lot of problems that you can't escape from and should have some knowledge about. First thing we'll start with is doubling, which happens at around 20 to 70 milliseconds. Now, this is going to give us a lot of problems that can be difficult to manage. And so therefore, if you're planning on doubling, I recommend using an actual doubling plugin. However, maybe what these issues will give you is something that you want. And these issues that I'm talking about that we are going to address are phase issues. So, what are phase issues? Well, to get an idea of what a phase issue is, we're going to pretend like this here is our sound wave. Upwards is positive force and downwards is negative force. Much like the speakers move. Your speakers will push outwards, which is positive force, or will pull in and create negative force. What phase issues are is if we were to take these and interlace them like this. Now what you're seeing is an equal negative pressure to an equal positive pressure. As this is going up 1, this one is going down 1. And because of this, we're going to get cancellation. Think about it. If the speaker is being told to go out just as far as it's being told to go in, where is it going to go? It's only when one of these overpowers the other that we're going to get any movement. If we were to make one of these smaller, then we would still get movement, but it would be canceled out by about half, based off the fact that we're traveling about half the distance in this bottom one down here. Or if they were both going the same direction, we would then add amplitude to this specific frequency range. And I say this specific frequency range because frequencies consist of waves like this, pulsing and alternating at different frequencies. If it's more frequent, it's a higher frequency. If it's less frequent, it's a lower frequency. So what if it was more frequent or a higher frequency? Now we've got 2 more sets of waves here, both offset the same amount, but more frequent or at a higher frequency. And if you'll notice, I've got 2 more sets of waves here that are more frequent or at a higher frequency. I'm going to switch this back here. I'm going to switch this one here so that they're starting out both positive. Now, if we'll look, these ones here, you can see, are canceling each other out, perfect replicas. This frequency here, though, that is starting at the same exact moment is showing us something a little bit different. Neither of these are in phase. In phase would be like this. Anything else is out of phase, and we're going to be doing adding and subtracting of the upside of the waveform to the downside of the waveform, which is going to cancel out and double different frequencies at different levels. And this is the idea of phase cancellation and phase issues. Now, this phenomenon of boosting and cutting specific frequencies at specific places create what's called a comb filter. It's called a comb filter because it's going to remove some frequencies and build others, and it creates somewhat of the look of a comb. Now, I don't know the mathematics or numbers that are used by mathematicians or scientists who actually study this stuff. However, even if I did, I wouldn't know how to read it. P.S. That's a real equation. And I don't even know how to read it well enough to know if it even has anything to do with what I'm talking to you about. According to what I was reading, though, it should be. I think. I was having a hard time with the read too, so I don't know. But all that to say, I have no clue when, what, or how phase issues are specifically going to happen, and most likely neither do you. What we can know, though, when using these delays is about where our phasing issue is and how much. And to do this, I'm going to use a cool plugin from Voxengo called the correlometer. What we have here is our vocal coming in, running into a delay. We're going to pan the delay far left. We also have it running into a dry track, just so we can pan that far right, which is going to run into our correlometer. The correlometer works by checking the left signal to the right signal and figuring out what the phase looks like. So if we turn the delay off and we look at the correlometer,
tell me, babe, you wanna leave this town?
Green all the way across, correlates perfectly. So the reason for this is because we're getting the same exact signal on our left and right channel. What if we turn the delay on?
Tell me, babe, you wanna leave this town?
Now we've got something else happening. In the correlometer, anything in the green is good. That means things are phasing the same direction, which is additive, and is things working together instead of fighting. Anything at the center line is fine. Anything below the center line is when you're starting to reduce and pull frequencies out. Red is bad. We don't want red. But when using a delay, you cannot escape red. So I'm going to get rid of all of this, and we're going to move our delay time of our delay between the 20-70 millisecond range. We would have doubles. And let's watch the correlometer.
I'm saying, love her if you wanna go on down. 'Cause down there we were made for bigger things. And this place keeps killing our dreams. Let's go, love. I'm saying, ain't you tired of waiting?
And as you can see, as I moved this delay time, we're going to get different levels of phasing at different frequency ranges. This is because, much like I showed you with those little LFOs with the waves going up and down, as you moved it to the side, some will cancel out completely, while others will just fight each other a bit, and some will even double each other. And I don't mean double as in doubling what we're doing here. I mean, it'll help amplify it. It'll be completely in phase. So what we're going for when we're adding a delay is we're going for as close to the center line or above it as we can. Now, if we move this knob here, we can completely mono this signal. That way, as we listen, we're not hearing it separated in headphones, and we're going to really hear the phase happening. Now, instead of watching the correlometer, let's listen, and you will hear some frequencies becoming thinner while some become fuller.
Tell me, babe, you wanna leave this town? I'm saying, love her if you wanna go on down. 'Cause down there we were made for bigger things. And this place keeps killing our dreams. And let's go, love. I'm saying, ain't you tired of waiting? We can leave this whole place behind, yeah.
And as you can hear, and as you could see when I was using the correlometer, it doesn't really matter where we move that delay to, we're going to lose some frequency content somewhere. And if this isn't the effect we want, we have to consider how to manage this problem. And generally, this problem is managed by slight pitch changes, slight modulation, and more, so that we throw the original double so out of sync that we don't continue to have the same phase issues, and any phase issues we do have are randomized enough that it minimizes our ability to lock into it. Adversely, on the other hand, this same kind of modulation and effects is actually how phasers and other effects like that are made. With that being said, my recommendation is to use a doubler plugin to make this a lot simpler for you. Now, another way to combat this is by trying to move phase. There's phase rotation plugins that actually let you rotate phase, and this will help change the synchronization. You can also flip phase. If you're using FL Studio, we can flip phase by clicking our reverse polarity button. Now, while this will make a change, when using a delay like this, we're still generally going to have issues regardless because we threw things out of phase. So if we listen though,
Tell me, babe, you wanna leave this town? I'm saying, love it if you wanna go on down.
if you listen closely, you should have been able to hear a little bit of a difference. You'll hear about people fixing phase by flipping polarity, because generally what happens is if I record a snare, for example, with two microphones, one microphone might start going down while the other goes up, but they're going to be the exact same snare minus small subtle differences due to room placement. If it's the same exact snare and you flip it, now all of the frequencies should be playing around the same time versus almost all of those frequencies playing at a different time. We, however, can't do this when adding a delay, though, because we're unsyncing our sound. People often fix these phasing issues by lining the timing up better, along with making sure the phase is headed the correct direction for each of these duplicated sounds, generally after recording a multiple mic session. We, however, are delaying it and throwing it out of phase. So no matter what we do, we're going to be fighting with some phase issues. It's just the nature of the delay. Now, since we already have our delay on one side and our vocal on the other, I'll turn this back to stereo and we will talk about the Haas effect. The Haas effect is a 5 to 30 millisecond delay. And the reason it's so short is because it takes the human perception with hearing about 30 milliseconds to differentiate a source sound and a reflection. So what I mean by that is if you keep it under 30 milliseconds, then your echo will actually sound like it's the same sound. It creates a psychoacoustical effect. So if we're having a delayed sound play on one side and our source sound on the other, this sound will play first, this one will play second. It'll appear to be the same sound, but now, much like sound travels when something's on the right of you and hits the right side of your head and then reaches the left side later, we're going to be imitating the placement of your source sound being to the right of you. So the Haas effect is good for creating a sense of panning while still keeping things relatively center and equal with volume. Let's take a listen.
Tell me, babe, you wanna leave this town? I'm saying, love it if you wanna go on down. 'Cause darling, we were made for bigger things.
So listening to that sounds pretty good. Just like when we did the double though, we can still have some phasing and combing issues. While our delay and our source signal are kept in their own left or right channels, these combing or phasing issues won't be as apparent. However, when we start bringing these things mono, or when they're played back in specific scenarios, these issues might become more apparent. Now, when using the Haas effect, even though the sound gets wider, the center will always get thinner. If we check this out.
Tell me, babe, you wanna leave this town? I'm saying, love it if you wanna go on down. 'Cause darling, we were made for bigger things. And this place keeps killing our dreams.
Now, this doesn't mean there's not a place for the Haas effect. The Haas effect is an amazing tool. These are just things to keep in mind while you're using a delay for things like the Haas effect. Now, as we leave the limits of the 70 millisecond delay time that we had when we did the double, we start moving into the world of the slapback delay. It's called a slapback because if you were to hit somebody and they hit you back, somewhere in the 70 to 120 millisecond range to be exact, you'd get a slap back. So moving into the 70 to 120 millisecond range, let's see if we're far enough to avoid phasing.
Tell me, babe, you wanna leave this town? I'm saying, love it if you wanna go on down. 'Cause darling, we were made for bigger things. And this place keeps killing our dreams. Let's go.
That looks pretty good. Now, Warren, I thought this was a delay video, not a phasing video. So why are you telling me so much about phasing? And I guess the short answer is because you can't escape it. Phase issues are going to basically EQ the sounds you're using by reducing frequencies in those areas, much like an EQ would. And much like you wouldn't take a vocal and start EQing out a bunch of frequencies without having any reason to do so, you wouldn't want to do the same thing to your vocals by using a delay. So if you add one of these delays and all of a sudden the fundamentals in your vocal are missing, and that's something you hear and you're sitting there fighting your EQ, don't fight the EQ, turn your delay off, check. If turning your delay off fixes the problem, change your delay time. I want to prep you to be effective. I don't want to just tell you, here's how you do a slapback, and then have you fighting yourself about it until you're 5-10 years down the road as a producer and you finally start realizing what's been happening all along whenever you use your delay. It's a little bit drastic and exaggerative, but you get what I'm saying. So the next question is, with me making phase sound big and scary, how much do we actually have to worry about phase? And my answer to you is, if your song sounds good, don't worry about it. It's not always practical to open up a corralometer every time you want to use the delay and route a bunch of channels just to check your left and right. If you're hearing issues, this is something you can do to troubleshoot, but you're not going to do that every single time you're using a delay, or most people wouldn't want to bother using a delay. It's just not fun. The key isn't necessarily what your phase is, but what's coming out of the speakers. And I say that because if what's playing out of the speakers matters and the listener is listening to that and it sounds good, then you aren't going to have to sit there and explain phase to them. And if it sounds bad, you're not going to be able to explain to every single listener, well, if it's phasing issues and if I would have just got it right, it's not going to happen. It's not practical. So does it sound good? Because if you can't escape the phasing and you have to deal with it, the real question is, does it sound good? So let's set up a slapback delay, no corralometer, just us and our delay controls.
I'm saying, love it if you wanna go on down. 'Cause darling, we were made for bigger things. And this place keeps killing our dreams.
Okay, I like it there. I don't want any low frequency buildup, so I'm going to start touching my EQ. These are EQ cutoffs. It's like a high pass, low pass filter. So we're going to let our high pass at around 700 hertz. Everything that's below 700 will cut off. I'm going to give it a listen, see if I want to change it.
Tell me, babe, you wanna leave this town? I'm saying, love it if you wanna.
Okay, I will do the same exact thing for the high end. I don't want a buildup of sibilance or anything too sharp, not too breathy. So let's give it a go.
Tell me, babe, you wanna leave this town? I'm saying, love it if you wanna go on down. 'Cause darling, we were made for bigger things. And this place keeps killing our dreams. Let's go.
Cool. Now that we've got that, we're going to jump over to our diffuse, the DIFF. You'll see this in a lot of these. Diffusion basically acts the same way it would in a reverb. However, with one single reflection, I can't quite say how that works, besides the fact that it's just going to spread and wash it out more. So by spreading this out, we can make it less artifacty and less boxy or tonal. So let's wash it out until it's smooth.
Tell me, babe, you wanna leave this town? I'm saying, love it if you wanna go on down. 'Cause darling, we were made for bigger things. And this place keeps killing our dreams. Let's go, love. I'm saying, ain't you tired of waiting? We could leave this whole place behind, yeah.
Okay, now that I did that, I'm hearing it smooth out, but I'm also hearing a little bit going on in the high end I don't like. I'll break down my EQ.
Tell me, babe, you wanna leave this town? I'm saying, love her if you wanna go on down.
Darken it up a little bit. But now that I've darkened it up, we have a drive here. And this is going to add some distortion and some color to our delay. This will also give us a little bit of high end back because naturally distortion, saturation adds some high end.
Tell me, babe, you wanna leave this town? I'm saying, love her if you wanna go on down.
We'll change the age. This isn't something you'll necessarily see in all delays or most delays for that matter. But this is going to change the sound of this distortion or color. And so I want to change it to try and suit my needs better.
Tell me, babe, you wanna leave this town? I'm saying, love her if you wanna go. Tell me, babe, you wanna leave this town? I'm saying, love her if you wanna go on down.
Sure, why not? I'll leave it about right there. Now, even with the color and all of that, I still just feel like the high end's doing something I don't like. And this, of course, would be different in context of an actual mix. But what I'm going to approach is the flutter. Wow and flutter is something that you're going to see a lot, and it's usually going to be represented as a mod or modulation. And wow and flutter are actually going to modulate our delay time or the speed of the playback. Because what would happen when tape would play and run around, like I was telling you about to give context, is the machine and the mechanisms wouldn't always pull the tape at the same exact pace. The tape could sometimes get hung up on something as it was pulling around it, if it wasn't clean or just in general, which would cause some drag, which would cause it to go through the delay slower. And the way this translated into how the high and low frequencies were put onto the tape and then later played back created what was called wow and flutter. This was also something that would happen with vinyls. Now, while I don't know the exact science or exactly how this works, what I do know is wow will be more audible in the low end and across a good majority of the frequency spectrum, while flutter is going to more affect the high end and give some good high end deterioration. So I'm going to turn up the flutter or turn it down, we'll see, to attempt to try and again tune in the high end to something I would like.
Tell me, babe, you wanna leave this town? I'm saying, love her if you wanna go on down.
I like that. Now that we've got that, I'm going to go ahead and turn my delay down.
Tell me, babe, you wanna leave this town? I'm saying, love her if you wanna go on down.
Just to make it something more suitable that I would actually like to hear with a slapback. And next, because I can and we have the options and I want to show you delay options, we're going to add some width. So this was monoed. I'll unmono it. This right here is going to be our actual stereo. And this here is going to be the difference between when the left and right channels hit. So I'll move my width up till I like it.
Tell me, babe, you wanna leave this town? I'm saying, love her if you wanna go on down. 'Cause darling, we were made for bigger things.
Okay, I like that. And now we'll add some spread.
Tell me, babe, you wanna leave this town? I'm saying, love her if you wanna go on down.
And now we have a solid slapback delay. And we just managed that slapback delay using all the controls available to us. If we play it with and without,
Tell me, babe, you wanna leave this town? Tell me, babe, you wanna leave this town?
cool stuff. So next, we're going to go over an echo style delay effect, as well as continue to go over these controls. So looking at this controls, we've already gone over this delay with milliseconds, but oftentimes these delays will sync up with your project. So I'm going to take this to a dotted eighth. I turned my diffusion off so it doesn't sound like it's just a reverb. We got our dotted eighth and a single, and if we take a listen, that is our single style delay. If we were to change this though, you're going to get to choose the time of your left and the time of your right separately. If we take a listen, I have one at a dotted eighth, one at a normal eighth. If I turn the feedback up, right, I could change one to a half note, for example, which is a lot slower. Quarter note. So this is cool for creating rhythmic effects between the left and right. If we go to ratio, this is going to be the same kind of stereo spread, except for the difference is it's going to go by a ratio based off of the one you have set. So now that I have a dotted eighth, if I do 50% ratio, that means that we're going to get a dotted eighth on one side, and we're going to get half of a dotted eighth on the other. You should have heard it left, right, left, right, left, right at an equal pace. Right? Our next option is going to be ping pong. Here's the cool thing about ping pong. This looks a lot like the dual, but the difference is that it has to finish one cycle before it starts the next. As you'll see, we got the original hit, we have our dotted quarter followed by an eighth, and then a dotted quarter followed by an eighth, again and again. Where if we did that on dual, dotted quarter and an eighth, so you would get the eighth on the right side the entire time. Here, it only plays the eighth after our dotted quarter. It has to finish a whole cycle before it starts again. Next thing we have, which is interesting, is quad. This is really cool for creating rolls. In our quad style on the Valhalla delay, we got the different taps we can turn on and off. All representing different speeds, creating interesting roll effects. And much like this, we also have different delay models. In our fruity delay, we have mono, which is going to mono our signal, then delay it. But we could also offset with this, which would take our monoed signal and offset the left and right channels. We have stereo, which allows for true stereo through the plugin. And again, we could offset the left and right channels. We have ping pong, which is ping pong. And then we just turn the delay off. And generally, you're going to see different models in every single different type of delay. Here we have dotted, straight, triplet, and free. These are just the different timing options. And besides that, we have a ping pong, and that's it, either on or off. And every delay you go to will have some kind of variance of the same stuff. Every single one of these plugins is generally going to have emulation types. Here we've got tape, hi-fi, and more. If we go back to our Baby Come Back plugin, we've got wide, analog, saucy, cheap. This is just going to emulate different types of equipment, along with different feelings in general that may or may not be associated with specific types of equipment. Here in Valhalla Delay, to take it a step further, we have past, present, and future as eras. Anything past is darker, future is brighter. And on top of there being these different types and emulations, we're also sometimes going to get ducking, like the ducking in Baby Come Back, which is fantastic because what it's going to do is duck your delay out of the way of your source signal without you having to go in and set up your own side chaining. Now that we've created your standard delay, listened to it, and talked about the controls, I've got two more techniques for you. So we're going to take this from a dotted to a regular quarter note. We're going to load up our fruity balance again, and we're going to create an automation clip. Because what we're going to do is create some vocal throws. Okay. I've got my automation set up, and you'll notice that this can be used to just take one phrase and set it in its own space. This can be an awesome effect when it just feels like something else needs to be there. And in the midst of the actual mix or an actual mix, this can be a great way to separate something someone is saying or add flavor. If we take a listen.
Tell me, babe, you wanna leave this town? I'm saying, love her if you wanna go, I'm down. 'Cause darling, we were made for bigger things. And this place keeps killing our dreams.
Smooth. Next, we're going to tackle an effect that is a bit more dangerous. For this example, I'm going to turn off our envelope there, and I am going to go get a drum loop. Now, first thing we're going to do is we're going to come in here and we're going to put a limiter And I suggest you do this with a limiter always, please. What I'm going to do is I'm going to send these drums through the same chain as our vocals, but I'm going to mute the dry ones, mute our delay, and set our limiter to about the peak of these. Cool. Now that I've got that, I'm going to turn our delay back on. I'm going to change this to a dotted eighth again. And this is why we added the delay, is we're going to start adding feedback, but something terrifying can happen when you add too much feedback. If you've ever seen someone stand in front of a speaker with a microphone and all of a sudden you get the noise that just builds up and blows people's ears out, yeah, this is the same thing. So don't go cranking this. Be cautious as you're moving it upwards. Because what it's doing is it's like if I was to stand really far away from a speaker, the speaker plays the sound comes into the microphone, sound travels through the microphone, back out the speaker. We're getting this loop that's constantly re-recording itself with a delay time that is associated to the distance between the speaker and the microphone. In this instance, it's going to perfectly equal a dotted eighth. It's very important, though, we know not to crank this. And that's also why we have the limiter as a safety net. So let's play this and set it somewhere we like. Cool. I like that. So let's turn the dry one on. Let's use this fruity balance, turn it down. Cool. So I got the levels about where I want them. I created a new automation clip, and we can even add another automation clip to make some room for the feedback loop that's coming in. And now if we listen, we've made room for the feedback loop coming in, as well as more to back out. And that's about it. This was kind of a long video, but if you stuck through it with me, awesome. I'm glad you stayed, because today we learned not only how phase affects all of our different delay techniques, but we learned multiple different delay techniques, starting from short delays like the Haas effect and double, all the way to automated things like throws and feedback loops, as well as explored all the different delay controls that were available to us within the few plugins we have. If this video was helpful, please let me know. If you liked the video, like the video. If you have any comments, please comment. I always appreciate a subscribe. It's Warren with Scale Audio, and adios.